Excellent. So I wanted to start off just quickly telling you a little bit about the two of us up here, and then we'll dig into some of the content, what we're looking to talk about. The first thing I wanted to sort of just get a feel for the room. How many people have been to either of Mark's talks earlier in the day? Okay, few hands. How many is this the first Windows Azure talk you've been to for the week? Okay, most people. Excellent. Okay, that will help us gauge a little bit. So my name's Corey Sanders. I'm a program manager in the Windows Azure team. I was responsible for and continue to work on the infrastructure as a service offering in Windows Azure. And I'm up here with Paul Stubbs.
Hey everyone, I'm Paul Stubbs. I'm an architect on the Azure Center of Excellence team in services, and I focus on integrations of SharePoint and Azure.
So the way we're going to work this is I'm going to start off and talk a little bit about Windows Azure, a little bit about infrastructure as a service, and kind of go into some technical details there. I'll sort of bounce back and forth a little bit between 200, 300, and try and keep my eyes on whether eyes are glazed over or there's interest and excitement. And then I'll hand it off, and Paul will then focus quite a bit more on sort of the SharePoint side of the house and sort of how that then plays into the things I talked about. So with that,
good.
I'll go ahead and
get started.
Get you off the stage here. I need my room. Okay. It's late in the day, too, so I'll try and be energetic if you're tired. Okay, so, exactly. That's excitement. I love it. Okay, the agenda. That's not the energetic part. So just to get started. Oh, I'm off. Okay. Do I need to stand here? Okay. Let me get started. So to start off, I wanted to just give you a quick view of sort of the cloud continuum as we see it in the Windows Azure team and at Microsoft as a whole. And so you sort of look at this, and the bottom axis is sort of the control and compat aspects of the platform, and the vertical axis is cost efficiency. And so you can sort of see, based on the arrow, moving from on-premise, where you're deploying, let's say, SharePoint, a SQL Server on premises, and here you have full hardware control. You can completely control the size scale. You drop in memory when you need to. You rewire things when you need to. And it really just lets you run things exactly how you run things all the time. It has a lot of reduced cost efficiency. You have to manage that hardware. You have to manage all aspects of that hardware and the details of what you're running in there. And for things like dev test, you have to organize who's running what when, and a lot of sort of cost impact there. When you sort of move up the chain, infrastructure as a service, which is what I'm focusing on today, this really takes away that hardware cost and sort of moves it into more of a rented and sort of a you don't have to care about model, right? You still have to worry about the app above the hardware, right? So you're renting the hardware, you are deploying based on that rented hardware, very fast, very quick to get going, but you're still managing the app. You're still, and in this case, SharePoint SQL, you're still paying that management cost. And then, of course, as you move the Office 365 side and you look at that, this is where really you're getting the most cost efficiency, right? And so you have all of the aspects and value that Office 365 gives you. You're not having to manage or control any aspects of that specific application. And so when you actually think about this hosting model and sort of the aspects of each one of these columns, the on-premises, infrastructure as a service, platform as a service, and then software as a service, the Office 365, you can sort of see as you move along which aspects management is you're required to do and which aspects is being managed for you. And one of the things that we do talk about a lot inside the team and across teams between Windows Azure and Office 365 is very much if Office 365 works for you, it's the right choice, right? And if you're coming and you're saying, well, I don't know which one to go for, Office 365 is the right choice if it works. And then we sort of fill in for the things that maybe it doesn't work, right? And there are a lot of examples, and I'm happy to stay after and talk more about those examples. But for the most part, that's kind of the focus that we do have in the team. Okay, so moving forward here, getting started. So when you look at Windows Azure Virtual Machines, which is the infrastructure as a service offering, we have sort of three big things that we think about: flexible, open, which I guess is I've never figured this out, what this marketing page is, a heart or like a sideways ice cream cone. I think it's a heart. Okay, and solid, which of course the mountains, that makes sense. From the flexible side, the whole idea is that you can spin these things up real fast. Spin them up fast, take them down fast, clean things up, restart, etc. A great example, actually, the hands-on labs that are running right now at this conference are running on virtual machines in Windows Azure. The main reason for that is they spin them up real fast, they wipe them away when people are done, and they start with fresh ones. And so it's a really great environment for that sort of thing. 1,800 virtual machines. It's a lot running in there. Open. So one of the big things we've really pushed this last year in Windows Azure is this open environment. It may be less interesting for you at this conference per se, but we do have this big focus on, again, we support Linux as part of the virtual machines. We have a lot of open stacks that we do support as part of the development model as well. And you really can just upload your own VHD with whatever aspects you want in there, and we sort of let you have it. And then, of course, solid. Right? The whole focus that we've had when we built this is SQL Server, SharePoint, and Active Directory as sort of the three big crucial points to tie together this virtual machine offering. So infrastructure service to us was those three work, and we can ship. And so those are the three teams we've actively worked with to go make sure it landed really, really well. So for the flexibility point, to sort of emphasize this just a little bit more, there's a few ways to get started, and I'm going to show you a few of these actually as we get going. One, of course, is the management portal, which I will show you in a few of the demos, where you can get things going with a very nice, pretty UI, which you've seen a few times, I think. Scripting, which I'll also show you, and I'm going to show you using PowerShell, where you can really create these things just by writing up a few PowerShell scripts, syncing them all up together, and running them as one sort of big batch operation, which we see a lot of folks do. They can set scheduled tasks. They spin things up at different times. It really gives a lot of power to that option without having to mess with the UI. And then, of course, the REST API. And the cool thing about the REST API, the management portal and the PowerShell scripts all just use the REST API. So there's no special operations that they get to use. And so you could go rebuild our management portal if you wanted to, using the REST APIs that we've made available. And so we do want to open that up and make sure programming is possible. For the images to select from, we have a bunch. We do have, obviously, the standard 2008 R2 and Windows 8 Server. We also have CentOS, SUSE, and Ubuntu. I'll actually go through the versions in a later slide. And we actually have a few more that I'll talk about as well, a SQL Server image and a BizTalk image. And then one of the interesting things that I'll spend more time on later is really the fact that this is persisted, right? So your OS disk, your data disk, all the writes that you're making to these guys, they are stored off in storage. And it's just Windows Azure Storage, which I'll talk a bit about, which really means you have complete access to all of these artifacts. You can go play with these VHDs, you can copy them around, and it gives you this complete access control. You can take them back out of the cloud, and so that really helps you manage your environment and try things, and then maybe decide it wasn't for you, or maybe decide it was great and try doing a lot more. Excellent. So just to kind of quickly get started, how does it work? And I'll show a quick demo of this here in a minute. The real sort of starting point is just go to the gallery. And you can go through the management portal, and you can create a new VM from that gallery, and then it will show up in your blob storage, and we boot from it, and we run from it. So let me actually show you what I mean. Excellent. OK. So just to get started, let me give you just a quick tour of what we've got here as part of the new management portal. So on the left, we have sort of all of the options that you can spin up. And if you went to Mark's earlier talk this morning, he kind of went through a big bunch of these. Scott covered a few of these in his talk involving websites. I'm going to spend most of my time here on the Virtual Machines tab, which is our infrastructure as a service offering. And so very, very quickly, you can just go in here, and you can say New, and it pops up. And I can say, OK, Virtual Machine, and go straight to Quick Create. And so with this, I have a few options now that I can quickly start with and get going. One is, of course, the DNS name. And so for this, I'll say demo, let's say Corey demo. Make sure it's not taken. I'm going to do, as you can see from the pull down, all the images that I just mentioned. I'm going to go ahead and do Server 2012. I'm going to make it small, so 1 core. Right now, I can go up to 8 cores with 14 gig memory. Pick a password. OK. And then I'll go pick a region. I say West US. And I'll go ahead and create that. OK. And it's off. So another sort of example, and I told you that you can do it both through the portal and you can also do it through the PowerShell scripts. I'll quickly pull up this example as well. And so here's what I've done. And I'm not going to spend a huge amount of time on this, but I do want to sort of show you and give you an example of what this looks like and sort of how easy this is. So I built sort of a PowerShell script. The key thing is that I, of course, import the module to do it. One aspect that you need to do as part of using PowerShell is we have this. Oh, that's a terrible circle. Look at that. I apologize. I design things better than I do circles. OK. You can go ahead and say, I want to import my published settings file. right? And the reason for this is that there's obviously a security mechanism for you to get access to your account and be able to do things against it. We try and make it extremely easy for you to be able to do this. And so it's a simple PowerShell command that you can call to go get this, this published setting files and then use it repeatedly. And you have that access then on that local box. And so for here, what I'm going to do is I'm actually going to, the image that I'm choosing, you can see is SQL Server. Okay? And of course, I'm picking my stored location. And so from there, I can go ahead and run. Let's go ahead and change the name, just in case. Actually. Okay, go ahead and save. Okay, and there we go. It does create a new VM, and it should be up and running. Well, soon. So you see this other VM that I just started, it's going through provisioning. I'll explain that in a little bit more detail later. And of course, we will see the machine that I just created here appear in the window here in a moment. Well, sort of while we're waiting, we can go back to the slides and keep talking. So disks and images. This is one that I do like to spend time on. It's a particularly interesting one if you're doing things like dev test, if you're manipulating or managing your system in such a way that you want to move things around. It's important to sort of understand the underlying system just a bit. And so I'll try and move through this relatively quickly to give you sort of this feel for it. So images and disks, we have two concepts in Windows Azure. One concept is the concept of an image. This means it's sort of been prepped for repeat usage. In Windows, that means sysprep. Actually, let me just get a feel for the room. How many people are familiar with sysprep? Oh, wow. I love this audience. Okay. Fantastic. So the image is really intended to be sort of this multi-use image, which means it's sysprepped. And then the platform, which I'll show you some pictures later, uses sysprep to do the provisioning that you just saw. And so all of the images that we have that are Microsoft-based images, the SQL, the BizTalk, the two Windows ones, are all sysprepped in the platform, and then we deploy using it. We sort of simulate sysprep using Linux. And so Linux has an agent in there that sort of simulates the sysprep process, cleans up certificates, et cetera, for all the good reasons to use sysprep. And so we also sort of simulate and have images for Linux as well. Having said that, there are lots, in fact, probably all the hands who raise their hands know that there are a lot of limitations with sysprep. SharePoint having a lot of limitations involved with sysprep. And so we knew that we needed to support this other concept that wasn't just image-based, which is the disk. Right? And so the idea here is that you can just take a VHD, you can put it in the cloud, and it'll boot. We're not going to set any username. We're not going to set any password. We're not going to configure it in any way. We are just taking that VHD and booting it. This has a lot of good things. It allows you to do a lot of powerful things. It does have a lot of risk with it. I'm sure you've seen this probably on premises when you move VHDs from one location to another. Sometimes the network doesn't really come up because it didn't expect that there would be only one NIC or two NICs. There are lots of sort of tricks and problems that you could hit in that regard. So we do always recommend you use sysprep. It does help clean a lot of that up, but we make sure that it is supported and that you can always go in and take a look at that disk if it doesn't boot and see why that didn't happen, perhaps looking at the logs and so on. Okay, so from those two concepts, the images that we have available, I've talked about these. We do have the two Windows ones. We have SQL Server 2012. We will be having more versions of SQL Server 2012 as we get closer to our GA launch date. And of course, BizTalk, the 2010 R2 CTP. I'm sure this audience is very interested as to why SharePoint isn't in this list. And I don't have anything explicitly to announce here, but we're working on it. And on the open source side, we have the two SUSE ones, OpenSUSE, and of course, SLES, and then CentOS and Ubuntu. And no questions about one's missing on the open source side. Just kidding, I'll take questions about it. Okay, so for those of you familiar with sysprep, let me just walk you through a little bit of what we're doing in provisioning, because this will help you if you're going to go build your own images. It helps you to sort of understand what we're doing under the hood to sort of watch out for some things that you may hit. And so if you're calling our API, or you're going through our portal, or you're using the PowerShell scripts and you say add server, and you supply things like hostname and password, what we're really doing under the hood is we're taking that information, passing it through the system, and we're creating a DVD. Right? It's pretty simple. We just create a DVD with an unattend file on it, and we store it in an account. And so this is really sort of that sort of classic unattend for sysprep solution. We'll take that stock image and we'll copy it into your account. And I'll show this here in a minute. And so you then now have a VHD that just appears in your account, which is that image that you just created. We put little locks on them to make sure you don't accidentally delete them when you're using them and when you're booting from them. Windows doesn't like it when its disk gets deleted. Linux doesn't either, actually, for that matter. So it'd be great if Linux could do that. OK, we create this VM. We put a little cache on there. And this cache is really intended for just the paging file. It's intended for some local data. It's not persistent. And then, of course, we will make the OS disk and the data disk appear onto the disk, onto the VM. They're actually still in Windows Azure Storage. And so writes and reads are going directly to Windows Azure Storage. And so I'll show you that you can see the revision date changing as the disk is being run, because the writes are going straight there. There's actually no local copy except some caching that's done for the OS disk. And so these appear in that VM, and then we'll take the ISO, and we'll mount that in there as well. And we'll boot the machine up. The ISO, of course, spins. It's a fun animation. And the machine goes through Windows setup, gets all set up, and you've got your machine ready to go use. And so let me quickly go back and show you what I was just talking about a little bit. So one thing you'll notice here, I've got the 4 disk, the one that I created through Quick Create. That one's ready, and I can connect to that. One of the things I wanted to show you here is the SQL one. If I go here and say, OK, let me go take a look at my disks, which is here, this tab up here, I can see these are the disks, and I can see which ones are running. And so you'll see here's the SQL one that's running. OK? And so if I actually look over here as to where it is, OK. There we go. So you see the location that it is this blob account, this storage account that I've got. It's terrible, I'm sorry. I should practice that. And so if I go take a look at that storage account, and what I'm going to use here is Cloud Explorer, which is a third-party tool that's really great at visualizing Windows Azure storage accounts. And so here you can see, let me just refresh this. And here is the SQL Server VHD that's running in my machine right now. It's actually booting. It's provisioning as we speak. And so you can sort of see the date modified is, of course, right now. Right? And so it is changing as we speak. I can do refresh, and there it went up a few seconds. And so that's writing to it as it goes. You add data disks to it. So this is, and so really interesting things that you can do is now I can say, OK, I've got this disk. Let's just go copy this. And let me go to this other location and hit paste. Because it's Windows Azure Storage, it's a shadow copy. And so it's a copy on write, so it's done. And so now I have taken this 32 gig VM that's running. Of course, it's running as we speak, so it's probably not advisable to just copy it while it's running. So not necessarily a best practice. But it is possible to do this. And so I could now go and mount this guy, and I can boot him. And it will come up and say, oh, it looks like you didn't shut down cleanly, because of course I didn't. But I have that backup, right? And I can go spin up another VM even if I wanted to from that. And so that's just the power of the underlying storage system. And to show you sort of a little bit more of the, let me go through sort of the full from gallery experience here, because this will show you more of what that provisioning process does. I will again, let's see. I'll do BizTalk on this one. OK, and so here again, the virtual machine name, so I can pick whatever machine name I want. Pick a password. And so all of this will end up in an unattend file. Pick a size. OK, and so here what's interesting is that, and I'll talk briefly about it later, I can pick standalone or I can pick to connect it to an existing VM. And so if I want to spin up, let's say, a SharePoint farm, and Paul will talk about this later, I can actually have these guys all connect to the same, all connect together such that they can talk to each other and sort of make a subnet connectivity between them. And so this is one way to do that. And I can pick the DNS name. Let's say I'm going to build a sort of an outward-facing solution. OK. Pick my storage account that I want to use. OK. And availability sets I will talk about later, but that's how you get high availability. And so that then allows me to go in, and I have just gone through and provisioned that full VM. OK, great. Let me go back. Excellent. OK. So as I mentioned, one of the really exciting things is this portability concept. So you saw me messing around with that VHD. That is just a standard VHD. And so it allows you to do some things, as I mentioned, with the disks. You can take your disk from the data center, and you can move that up into the cloud and boot it there. You can also take the disk that you created in the cloud and bring it back on premises, maybe for backup reasons, or you decided you wanted to burst back down. Whatever the reason may be, one of these VMs that I just created, I could take that and bring it back down, licensing permitting, of course. The other interesting thing is because this just is a standard, there's actually nothing that stops you from using other service providers as well. And so you now have the potential to do disaster recovery across multiple service providers. If you don't necessarily want to use just a single cloud provider, you can use multiple ones, you can use on-premise, and you can build quite a solution that allows you to have these guys existing in all over the place. And that's one of the big things why we feel really good about using this VHD model and using Windows Azure Storage as our backend, because it gives you this ability to move things around. So, one additional thing to sort of point out is that, like I mentioned before, you don't have to necessarily start with something in the cloud. You can actually bring your own. And so the way you'd necessarily do that is you'd go through, create your VHD, you'd upload that to storage, you can create a disk, and I'll actually show you that here in a minute, and then you can boot it, and your changes will again be copied to blob storage. So let me actually walk you through that just real fast. So you saw the SQL Server image that I created. So now I can go ahead and let me just actually copy this one that I already copied and bring him back here. Oops, I have to rename him first, don't I? Great. And so let me go back to the portal. Oh, great, everything's coming up here. And so what I can do is, like I was before, I can go to disks, but instead of seeing ones that I've already created, let me go in and say create disk. And so this will let me do SQL Server disk 2 and go into my storage account. And instead of, in the example I've used, I've copied it back and forth to sort of simulate this, but if you were doing it, you could have uploaded it and it would appear in your storage account, and then you can go in and do what I'm about to do here. And so from your VHDs, you can see the list. Let me go down and find, okay, there's SQL Server VHD 2. I can go ahead and open this one. I do want to say that this does have an operating system, which means I'll be able to boot from it. It's not just a data disk. And bring that in. And that's relatively instantaneous. I can now come over here, and let me go new again, and do from gallery. And this time I'm going to say my disks. Oh, didn't come in yet. Give me one moment. Oh, great, there it is. So again, I can go through from gallery, and I can come in and say, here are my disks. Third time's a charm. Come on in. Just go to virtual machines, go from gallery, and there it is. Exciting. Okay. And so from there now, the SQL Server Disk 2 is there. This is the guy I copied or uploaded, and now I can go in and say, yep, just let's go boot this guy. And you can see I still want to pick a name for him, just so I can keep track of him in my list. And size. But you see I can't actually, and of course the external. But you see I can't pick anything like host name or administrative password, because these are already embedded. It's a disk. It's not sysprep, so we can't change that. We're just booting it. Kind of go in here, and I'll go ahead and deploy. And that will simply boot that VHD. Okay. Let me come back here. So here's always the fun one. I do like to talk a little bit about this, because it is kind of it's a thorny topic, is what about licensing? So just to cover sort of the overview, Windows Server, this license is covered in the cloud. So you cannot bring a license from on-premise into the cloud. You can't bring the license from the cloud back on-premise, right? They stay where they are. So when you're running per hour in the cloud, the license is covered as part of that per hour price. And then on-premises, whatever licenses you have for Windows is covered there, right? So that's an important point. But however, for application, it's a little bit different. Application has two possible approaches. One is application mobility for SA, right, for software assurance users. And this allows you to actually take server application licenses and move them. And there's some caveats involving that, so it's worth sort of reading up on it. But it does allow you to move it. And so for things like SharePoint, like SQL, you can take these licenses and you can move them into the cloud and run them in the cloud in Windows Azure. We do have some options around per hour. So for example, SQL Server, not today, but when we launch, we'll have a per hour offer in the cloud, where maybe you don't want to buy a license on premises and bring it in the cloud, or you don't have any left, but you still want to spin up that SQL Server. In that case, you can pay for that license in the cloud in a per hour rate. And we'll have more of these as we progress, but we do think this is really valuable for things like dev test, where you may not have those licenses just sitting around and you want to use it for just a few hours. External applications, this is a very interesting sort of one-off conversation, one by one. I could probably talk 20 minutes about any vendor that you yelled out. Please don't yell at a vendor. And so spend a lot of time on that. It really is based on that vendor and that product. We are very aggressively working with a lot of vendors, working through sort of their value and what they want to do here in the cloud. But we do need to approach that as a one-by-one case. So I do also like to just touch on the problematic stuff in the cloud. If you are going to try and do any of these, I recommend you don't. They do have problems, and I will talk quickly about them. Hyper-V, you can't run Hyper-V on top of Hyper-V, so don't try and set up a virtual system in top of our virtual system. It actually just, Windows doesn't allow it. For DHCP and NLB, Network Load Balancer and DHCP, these both require broadcast, which our network doesn't allow. Broadcast or multicast you can't do, so if you have requirements around those, they won't work. Failover clustering is an interesting one. This is one we're actually actively working on, but today failover clustering, Windows clustering, these things don't work because of their intricate network requirements, but we are working on this. We're working with the clustering team and the SQL team, actually, and hopefully we'll have more to say here in the near future. BitLocker doesn't have a TPM chip. This is required to turn on BitLocker. You can use BitLocker to do just encryption on the data disk, but the OS disk is really what's sort of interesting about BitLocker, and unfortunately we don't have that hardware there. And of course, client OS. No client OSs are supported for licensing reasons. Okay, we'll leave some time for questions here at the end, because I'm sure there's some on this slide. Okay, storage backend. Let me just spend just a couple minutes talking about this. And then give you just sort of a sense of what we're dealing with. So the VM, like I said, the VM's a persistent drive. I showed you it in the back end. I showed you sort of that beautiful Cloud Explorer view of what it would look like. The key here is that we actually have triplicate copies of everything in Windows Azure Storage. So every write that you're doing is being copied 3 times for high durability. We do it really fast, I promise. But it is being copied 3 times for that high durability, which means any disk dies in our system, and you don't even know. Right? We're always sort of serving that data, we're serving that content. And this is sort of one of the cool values of Windows Azure with this shared storage environment, is these disks die, we move the data over, we replicate, and we're good to go. And we have a SLA around this, and SLA around data availability, et cetera. Because we also use Windows Azure Storage, it gives us the ability to do geo-replication as well. And so we have, by default, geo-replication turned on for any of these disks, which means we are copying them up to 400 miles away, and we are doing it in a relatively lazy way, but we are copying it out. The key thing here is that it means every write that you're making at some point will be copied 6 times. It's really hard to screw up 6 copies. So it is, you should feel really good about the data that's here. The geo-replication offers you this extra level of confidence for disaster recovery scenarios. And so this is one of the big reasons why we're excited about using Windows Azure Storage for each one of these disks, whether data or OS. The other question is sort of, what does persistent really mean? Right? We are running on commodity hardware. This hardware is, it does fail. It has failed. I've been called in when it gets failed. And so when that happens, the question becomes, well, what happens to your VM? So when the hardware dies and your VM's running on hardware that does fail, because these disks are all persistent in storage and your data is write-through, which means every write doesn't come back until it's been copied 3 times, it means we can simply reboot you on another piece of hardware, and it looks to you like it was just a crash. The VM crashed. That stinks. But the hardware is gone, actually, and we found new hardware for you, and we rebooted you there. And so this is one of the really cool things about what persistent really means to us. It means your data and your OS are actually in Windows Azure Storage, and the VM is really just a conduit for you to get to it. Right? And so the VM dies, the hardware dies, we go find a better place for you. right? And you don't even know, other than that hard reboot, which hopefully is just a few minutes. Cool. And so, another important and interesting aspect about Windows Azure Storage is sort of this disk layout. So I'm giving you sort of a view of what the disk layout on the physical machine looks like, and of course we make some space for the host OS and the temporary location that I mentioned where the paging file goes. But for your disks, we actually spread them out, right? And so we'll actually spread out across these multiple disks in Windows Azure Storage, taking advantage of the fact that we have thousands and thousands of disks, right? And so we respond to activity on disks by load balancing them. And so when you get placed on a disk, let's say with another guy who's maybe using his disk a lot, we'll detect that, we'll make another copy somewhere else, and we'll load balance you. Right? And so this really gives you, first of all, it tries to give you the most consistent performance you can get, while also trying to make sure that we respond to load in an appropriate way that you don't even have to care. Right? One of the side effects of this that's really interesting, the more you use your disk, the better the performance gets. Which is really sort of bizarre, but because you're using your disk pretty aggressively, storage will say, oh my goodness, we should load balance you better. And so you'll end up being spread more and more out throughout the system, getting more disks, getting more IOPS, et cetera. Right? And so it is kind of an interesting thing. It also then requires a little bit of warming up. Right? So if you spin up a VM and you start immediately running an I/O test on it, it will get better over time as we figure out what you're doing and how you're using it and make sure we respond. And so one of the cool things, but also somewhat of the changes in predictability that you see on premises when you move to the cloud, as we've sort of got more to work with, but it just takes some time to go respond. Cool. So for the disk layout, as I mentioned, we have sort of a few things. We have the OS disk, which is a SATA disk that pops in. This is persistent, and it will always be drive C. We also create this, and that shows drive C. We also have this temporary disk. And here's sort of an important point, and I just want to reiterate this. This is not persistent. This always shows up as drive D. We recognize that this probably isn't the best place to put this thing. And we've actually had a lot of feedback over your drive D can't be this drive. We do want to put a non-persistent one there. I'll give you a little insight into sort of this problem. We do want to put a non-persistent there because we want the paging file to not go to storage. Right? We don't even have to mess with the paging file going to Windows Azure Storage. So we put this drive there. Unfortunately, Windows forces it to be D when it's SATA and next. Right? And so we're sort of fighting a little bit on how best to do this. But today, your drive D, it will say temporary as the label. Don't put your database on it, please. It's amazing how many phone calls. So it means we've done something wrong, frankly, but this is my way of warning you. So don't put your database on it. It will not persist if the hardware fails. And that appears as drive D, and it does say temporary storage as the label. And then the last disk, if you add a data disk, and I will actually walk you through this, it will show up as a SCSI disk, and it will be persistent. And your data disk will always be, by default, completely write through, which means every write that you get a response back that says, yes, it's completed, has been written to Windows Azure Storage. The OS disk, by default, actually has a very small cache. And the reason we do this is because we optimize for boot time to make sure that that boot is as fast as possible. But it also means that we do encourage you not to put things like your database on the OS disk because that cache is there. Right? And so just sort of a heads up there. It's pretty small, but it's still worthwhile to keep in mind. OK. So just a couple data points here. The OS disk, maximum 127 gig, optimized for boot. You can have up to 16 data disks on an extra large VM, each one 1 terabyte. So this means if you do some interesting sort of RAID 0, you can go up to 16 terabytes on a single VM, and you can span across those disks. And maximizing performance, do use the data disk. That will be more performant than the OS disk simply because of the cache that I mentioned. The last thing that I always do like to talk about that gets some hems and haws sometimes, we do charge for transactions on disks. And this is, I don't want you to get caught up and confused when you sort of go play with this, hopefully, after my talk. We charge 1 million is a dime. So each one of your disk IOs now gets a minor charge. It can add up. Right? If you're just using an OS, it ends up being nowhere near the dominating cost. It's pretty small. But if you're using a SQL server with 16 disks pretty aggressively, this number can add up. So it's something to keep in mind as you approach your solution about thinking through how you're using your disk and what your I/O looks like, because you do get charged for it. But the storage space is relatively cheap, and of course, for usage on storage, you only pay for what you use. So if you create a 300 gig disk, you only fill up 150 gig, you only pay for 150 gig, right? So you're not paying for the full 300. There's one catch to this, one of which we're also working on, which is if you fill up to 150 and then delete back down to 1 or 2, storage doesn't know that you deleted because it's not been zeroed, right? So storage still thinks that you've used 150. And so 2 recommendations that you can have there. One, if you're always just growing, you don't care, right? There's no reason to bother. You just start with a terabyte disk and just keep growing. But if you're going to grow and shrink a lot, you may want to approach it with when you shrink back down a lot and you want to stay in that small space for a while, create another disk and copy it over, and then you can start fresh and not pay for it. We are building trim support. It's just not something that we have right now. It's more of a gotcha. Okay, cool. Let me show you one quick thing here with disks. This is one of the demos I do enjoy. I enjoy all the demos. Okay, let me do this. So I have Corey Server 2012 here. Let me go ahead and connect to this guy. And let me connect to this guy as well while we're waiting. And so I'm going to show you 2 things. Again, I'm going to show you through the portal, and I'm going to show you through PowerShell. So while these are connecting, let me go ahead and show you quickly through the portal. So if I'm working here in the portal, okay, this one looks like it came up. Okay, I'm in the portal here. I've got my Corey Server 2012. Very simply, go to Attach and click on it. Let me click away and come back here. Well, let's use PowerShell. That's more reliable anyway. All right. So here's what I've got for PowerShell. So you can see here, I've already got a small VM. I've got a new volume size F here deployed. And so what I'm going to go do here in let me do one more go. No, okay. In PowerShell, I've actually got an add data disk here. And so it's pretty simple. Similar sort of setup. I pick the VM name, the cloud service name, which is sort of the container for that VM, and the disk name, which in this case, it's large data disk now, but that's the one I've already attached. So let me go to my disks and say which one do I want. Okay, let's do the medium data disk on this time. Okay. So go back, type in medium data disk here. And let me just zoom in here. You can see here I can pick the LUN that I'm attaching it to. So if I want to attach to LUN 2, 3, 4, whatever, I can go up to 16 on that one. And so let's just go to 3 here. Okay, save it and let's run it. Great. Okay, and that update is in progress. So let me pull this up here and just make sure we've got it. Okay, so you can see here I've got FDC. I am attaching a disk that I've already formatted, right? So it will show up, hopefully, with the drive letter. While we're waiting, let me go back. I'm not giving up. This makes me sad. All right. You're right. You're right. Okay, while that's running here, let's see. What? There. Okay, well, this one came up, so that's exciting. The one that I did through PowerShell worked. Exciting. It means it does work. So here you see I have a medium disk here. This is one I've already formatted. This one's 400 gig. The large one is, of course, 800 gig, and I can go fill these up. And, of course, through PowerShell, I can take this away, put it somewhere else, right? And it allows me to sort of just play with these disks as I want to. And so let's see here. Now that I refreshed, do I dare? Hey, look at that. Okay. Here, now I can attach disks, so I can do similar to what I just did, or I can attach an empty disk. And so this is very simple. I can go in and say, great, where in storage do I want to put this? This seems okay. And so I'm going to give, what's the, let's see, data disk demo. And I can pick the size. And so in this case, let's go 700 gig. And from there, the platform will create a VHD for me, put it into my storage account, and then attach it. Right? One important point, though, is that it will attach it. It's just a blank VHD. So it's not been formatted, and it won't be onlined. Right? And so you need to go into the VM, and you need to format it so that it pops up and shows a drive letter. But you should be all used to that. And then once you format it, then you can take it away and add it back, and it will always get that drive letter. Cool. So that's my fun with data disks. It was fun. I think so. Okay. Let me finish here with a few more points, and then I'm going to turn it over to Paul and let him sort of take this learning and move on to SharePoint and focus there. So networking and high availability. This is pretty important when you look at something like a SharePoint application. Right? And you're looking at both the front end and the SQL Server in your back end, and even perhaps the Active Directory. And we have two main concepts here that are somewhat separate but work really well together. So one is the availability set. And so this is a concept I mentioned. The key point here is that this is you saying these two guys belong together, right? And so if you're saying this for a SharePoint front end, you're saying this for a SQL Server back end, you're saying they belong together, and it's a clue to the platform to do things like this. When you say availability set, we say, OK, well, we understand that we have two racks here, right? And there's a single point of failure on the top of these two racks, which means we're not going to put both of your VMs on the same rack. We're going to make sure we span multiple racks, make sure we span multiple machines. Right? And so it gives you this higher availability than you can get by just saying these three VMs should be deployed. You also can set up another concept, which of course is the load balanced traffic endpoint. And you can say, I want an endpoint with load balanced traffic, either TCP or UDP, talking to these instances. So for your SharePoint front ends, let's say you have, let's say, 3 here, and you put them all in an availability set, so we put them in 3 racks. And then you say, I have a load balance set, and so we actually create the load balancer on your behalf, probe the instances based on their health, and you can set up different types of probes that you may want to use, whether it's just TCP or whether it's actually using an HTTP endpoint. And so when a rack, let's say, goes down, which this actually is pretty rare, but it has happened where we lose a whole rack, that VM's gone. The load balancer just disconnects from that one VM, and the other 2 take on the extra load. They got bigger. That's what that meant. OK. Cool. So from a protocol and endpoints point, we have UDP traffic supported both at both exterior and within the system. We also have all IP-based protocol VM to VM. And so this is a pretty critical one for things like Active Directory. It has pretty intense VM to VM protocol expectations to work. We have tested and made sure that they do work. It allows you to do things like ICMP, so you can ping. In fact, one of the most exciting demos that I used to do was I used to connect 2 VMs and ping them. I don't get out much. So we do enjoy our demos involving ping. And you can also do the custom load balance. As I mentioned before, you can set this up. You can make sure that it responds to an HTTP, just a 200, for example, or you can just use TCP on that. Great. So the last thing I'm going to cover, and I'm covering it very briefly, if you are interested in a lot more on virtual networks, Mark does a huge amount on this in the previous session, and it'll all be recorded. And of course, Paul will talk a little bit about this both now and in a later session. But the key point with virtual networks that's really cool, it allows you to connect to your on-premise network in such a way that you extend your corporate network into the cloud. Right? And so there's kind of 2 usage cases. One is just creating a virtual network between your VMs. And so when you're running in as a SharePoint farm, you'll very likely want to do this. And so you can pick up the VMs, you can pick the subnets that you want those VMs to deploy, and most importantly, you can pick the DNS IP. And so when you deploy Active Directory DNS in your SharePoint farm, you can specify, this is the DNS IP that I want everyone to talk to. And then we send that via DHCP to all the VMs in that virtual network. Right? And so you don't have to configure that. In fact, you shouldn't configure that, because if hardware fails, we want to make sure it picks it back up again. And so that's one of the really powerful things that this gives you, is because it's virtualized, which means we can give consistent IPs once you're deployed in there. So even if the hardware fails, even if we move your VM, whatever may happen in those operations, we actually will reassign it the same IP address. And you can have the same IP address as someone else, because it's all virtualized to your VM, so it doesn't matter, right? We can virtualize the same IP address to everyone in the world, and it would still work fine. And so that's one of the really cool things about virtual networks. The main reason why we had to do that is because the goal is to connect to your on-premise network. We obviously can't enforce the IP range that you need to go select for these VMs. Right? You need to say, look, I have this IP range already selected. I have this that I can carve out for the cloud, which means that's what my VMs are going to be. Here's my subnet range. Please give the VMs the IP ranges that I've said. And so that's why we had to do this virtualization, because for you to connect to your on-premise network, you need to be able to carve out that space, right? And so what we've seen a lot, in fact, our IT department did this. We've seen a lot of people using this to create a secure connection on-premise and then actually close the door to external access. And so what our IT department did, they spun up a SharePoint farm. They connected it on-premises. They used Active Directory on-premises to connect. And then they replicated that into the cloud. And they got it all working. And then they shut all external internet-facing endpoints to that SharePoint farm and kept it only internal. Right? And so the only way to access that farm was through the VPN device. And so it gave them that sense of confidence and security. It was a Fizz deployment. It gave them that sense of confidence and security while also allowing them to use the cloud for that SharePoint Active Directory deployment. And so it was a great proof of concept. We did it before we shipped, and we actually waited for them to say it was good before we shipped. And so that was one of the really great things. And it allows these hybrid scenarios to really blossom. Right? It allows you to sort of treat these VMs as if they're part of your network. The key sort of important caveat that I always like to call out there, they are not actually a part, sort of right down the hall from your office, right? They are, in fact, many miles away. They have a lot of latency involved. So you do want to make sure you plan appropriately. The way I like to talk about it, think of it as a remote office, right? Think of it as you have one office here and one office there. Don't think of it as machines that are down the hall that you can sort of treat that way. Okay. Cool. And we will have time afterwards for some questions. So applications. Just to spend a minute on this, and then I'm going to call Paul up here. So like I mentioned before, there are really 3 big applications that we focused on. And we focused on these 3 for a couple reasons. SQL Server, Windows Server with Active Directory, and SharePoint. And Windows Server in general, but Active Directory specifically. We focused on these 3 for a few reasons. They're probably the most popular ones for people to ask, hey, can I run this in Windows Azure? I have limitations running sort of the software as a service or platform as a service solution. Will this work? Can I do it? They end up being characteristic workloads, right? So SQL Server has defined our disk performance exit criteria. They came in and said, it has to be this or you can't ship. We pushed on them, and they said nope. And so we tried to ship, and they said nope. And so that's been sort of a great experience for us, because that line ends up being the same line that the Mongo guys likely want. It ends up being the same line that the Cassandra guys likely want. Right? It ends up being the same guys that the Oracle guys may want. Right? And so they end up being this characteristic workload that helps define what we need to do, but they're down the street from us. So it makes it such a much easier conversation. Active Directory, similarly, they have very intense VM-to-VM connectivity issues. In fact, one of the early parts of our testing, we deployed an Active Directory solution in the cloud, and fragmented UDP is actually required to make Active Directory work. I didn't even know what fragmented UDP was until they said it didn't work. And so they sent us this email and said, hey, this doesn't work. And our team, thinking very much in the old days of platform as a service, wrote back and said, well, can you change your app? The answer was no, it's Active Directory. So they can't change. We need to change. And we did. And so it ended up being sort of this great learning experience for us that we can't say that anymore. Right? The app comes to us. We don't make the app change. Right? And then, of course, SharePoint. SharePoint sort of put all the pieces together with the requirements on Active Directory and SQL. It also has been this complicated front end, and so it ended up being a great sort of characteristic front end application. And sort of with that, I will finish up with my slide to hand off to Paul that he didn't know I had changed. And so, one of the things that I do like to mention. We also focused on the Microsoft applications because we do have this concept of this joint support, the joint sort of business model around these applications running in Windows Azure, that they are better, right? And so the big focus that we've had is that they better be better. And so we've worked very closely with the support teams to bring the SharePoint, the SQL, the Windows Azure support guys all together to make sure that they're all sort of talking the same language, working really well together, and the sales teams all understand sort of the different aspects they're in. And so that's one of the main reasons for this. The location of the boxes have no bearing on anything. Okay. With that, let me introduce back up here Paul, so we can talk quite a bit more here about SharePoint specifically using what I just talked.
Great, thanks. So you can see the only person in the photo with their oar actually in the water rowing, right? So, good. So, everything Corey's taught you is really the foundation, the fundamentals on how to build and use applications on this platform. And the first component that we need as a SharePoint farm is SQL, right? But the idea is really that it's virtualization. Applications just work. So there's not a lot of things you have to do. However you install SQL today is the way you install SQL in a virtual machine, right? You fire up a virtual machine, Windows Server, you run the SQL setup routine, you go through the wizard, and then boom, you have SQL Server. That's all it takes. Now, there are a few things that you should do. There are a few best practices that we're working on, and they're still kind of in flux and as we go along. But, one of the things is put your temp DB on the D drive, right? Like, that's a great spot for the temp DB. I wouldn't put your other, as Corey said, don't put your real database on there. Don't put anything on there that you want to get back later. But, your SQL databases really map to virtual machines in storage. So if I have 2 SQL servers in a high availability mode or in mirroring, I can have those spread across databases that are VHDs, like Corey showed you, attaching a data disk. And I can attach up to 16 data disks, and then I can use the storage pool features of Windows Server 2012 to put them into a storage pool, and then I can slice those up into virtual disks inside that storage pool as I need space. So I could create a 16 terabyte virtual storage pool, and then create 8 terabyte virtual disks out of that pool if I want to, right? So there's lots of options for that you can do with that. But the other kind of nuance here is that I can put those VHDs in storage accounts, and then I can spread across the characteristics of storage accounts. And there are some limitations to storage accounts today and how much transactions and how much load you can do. But you can actually spread across multiple storage accounts. So there's nothing in the system that says, hey, I have to have all my VHDs in a single storage account. I could put all 16 of my VHDs in separate storage accounts and still pool them together as one virtual disk, and I'd actually be writing across separate storage accounts. So these kind of patterns are things that you can do, and that we have other guidance that we'll publish about how to do that. But the thing to take away is it's just SQL Server. However you set up and run SQL Server today is really the way that you set it up and do it today. Now, these other boxes and lines are really around some boundaries. We talked about availability sets. Corey talked a little bit about the affinity group and virtual networking. And we also have the cloud service boundary. So in the old days, when we just had PaaS, we had this concept of hosted services, which are now called cloud services. And that was the boundary. So anything within that hosted service or cloud service could talk freely to each other. Well, now we have this concept of the virtual network as the container. So the virtual network becomes a container of cloud services. So all the cloud services that are contained within a virtual network can talk freely amongst themselves. So that works out really good in the next pattern that you'll see here. So the thing we have here is Active Directory. So the next component that we need for our SharePoint farm is Active Directory. And so here we can stand up a cloud service for Active Directory. We can define the subnet for this. Normally what we do, we define a /29 subnet, because then that isolates us to just a couple of machines, and we can guarantee and we know what that IP address is when we spin it up. But once we have our Active Directory in its own cloud service, because we want that to come up first, because we have dynamic IPs, so we need that to start up first, we can then put our applications, whether it's SQL Server or whatever you have, in another cloud service within your same virtual network. And that cloud service with the application in it can now talk to your cloud service with your AD in it, right? And that's the basic pattern for any application that you would write. Now you can take that virtual network and you can connect it back to your physical network on premise through the VPN tunnel, and that's a level 2 network tunnel through your Cisco and Juniper router. So you just take that to your network guy, have him plug that in, the configuration information, and plug that gateway in. If you go back and look at Mark's talk this morning, he goes into some more detail about that. Now with your Active Directory, you also want to think about how do you spread your Active Directory out. You probably don't want to put your Active Directory data store on the same disk or on the OS disk. So just like you would with SQL Server, you put your database on data disk, install the application on the OS disk, and you'll have in essence, 2 files in storage that you'll be using. Now the last one, and this is kind of why we're all here, how do we pull all of those things together to build a SharePoint farm? And so this is really the pattern that you'll have for building your SharePoint farms. You'll stand up a virtual network, you'll stand up a cloud service that contains Active Directory, you'll stand up your cloud service that has SQL Server in it, and at this point, there's lots of options. And for simplicity, the slide shows one cloud service with everything else other than AD. But you may have reasons to put SQL in their own cloud service, your app servers in their own cloud service, your web front ends in your own cloud service. It just depends on how you want to set that up. It's not really too many hard pros and cons of doing it either way. But to give you some options. So we have our cloud service, which has our farm in it. We have our Active Directory, which is a cloud service. Those two are wrapped up within their virtual network. And then we could tunnel back for doing applications. Maybe we're running SAP or something on-premise, and our SharePoint farm needs to communicate back to some on-premise data store. The virtual private network will take care of that. So in this scenario, I have 2 app servers. That could be your central admin machines, load balanced for availability. We also have our WAC servers, our web application servers running, and we could have 2 of those for availability. And then all the other services you could spread out just like you would following all the same SharePoint guidance that you have on premise, whether you want to stand up, an Excel services machine or a Word services machine or search servers or whatever you want to do, you can spread those out to as many VMs as you want to use. And then we have a number of web front ends. So as you know, SharePoint servers are all the same. The only thing that defines a SharePoint server are the services that are running. So if there are no services running, we call that a web front end. If all the services are running, we call it an app server. If the search service is running, we call it a search server. So really those machines can come from a single template, and you can just create instances of them and then decide which services you want to turn on any one of those machines to do that. So in the normal pattern, you have a number of web front ends, normally 2, maybe 3. And then what we can do is we can turn on endpoints, and the endpoints are how traffic gets to your farm. Now, by default, when you install a virtual machine, you get a single endpoint. Does anybody know what that endpoint is to? RDP, right? So in order for us to actually RDP into a machine, we have an endpoint created for us. The problem is that a cloud service is the boundary for your namespace. So if you set up Corey's demo.cloudapp.net, like you saw him do today, that would be the name of his entry into his cloud service. So the problem is we have all these machines. How do I map port 3389 to all those machines? Because I only have one name, right? So what happens is you have an inbound IP address and an internal IP address. So in this case, we can say we're going to map port 80 or port 443 to port 80 on an inbound machine. Now with RDP, all those have to be unique, so we say some random inbound port 55100 maps to 3389 on this machine. On this machine, it's 5602 maps to 3389 on this machine. And so all the machines have a random inbound RDP number mapped to the internal 3389. And you can totally change that to be whatever you want to, or you could turn that off in the case that Corey mentioned about wanting to limit external access. But we can also map port 2013 or whatever you called your central admin port to your central admin machines. That way your administrators can go in and do central admin stuff on those machines as well. But now interestingly, we have our web front ends, and the inbound port is port 80, and the internal port is port 80 for all of those machines. So what happens? So Azure automatically sets up a load balancer for us that says, hey, if you have a bunch of endpoints that all have the same, they must be load balanced. And so Azure will set up a load balancer for us for those machines, which is exactly what we want, right? We want traffic to come into our site and be load balanced across our web front ends. So let's take a look at what this looks like. So All right, let me open a new instance here. So here's the account we have, and we can see first by default all the items are just rolled up. But if we look at our cloud services, if you remember from the diagram that we really had two cloud services. We had the first one, which was containing the Active Directory, and then we had the second one, which was the rest of the farm. So if we drill into the farm cloud service, what we can see is that for this cloud service, I'm using 18 cores. So you can see the number of cores I'm using for this farm. So remember, Corey talked about the hands-on lab, and the hands-on lab, we're using 14,000 cores. So for this, it's a fairly small farm. Then what I can do is I can actually see information about the cloud service. So for example, I can see here what the entry point to that cloud service is. We can see the instances that are running. So here are all the virtual machines that are in that cloud service. So if you remember my diagram as a container, these are the virtual machines that are running in that cloud service. We can look at an individual virtual machine. So here's our app server that we have running. The app server itself is using 8 cores. And I have an endpoint turned on. And you can see the endpoint has a random public port for the RDP, and then the 3389 for RDP. But I've also mapped the central admin port number so that I can actually log into central admin from this machine. We can come back to the dashboard, and connecting is, as you saw Corey do earlier, a simple RDP connection. So now you can see that here's our SharePoint site running. So we have our SharePoint 2013 site running. One of the things we can see here is I have central admin. So, oops. So the port number at the top here is our central admin on port 2013. We can see that I have my site here, which is just this site, because by default I'm coming into the web front ends, but the app server itself can also serve as a web front end if you wanted to do that as well. In this case, I'm not passing web traffic to it other than the central admin site. So I can see this is the internal address, but I can also see that this is the external address here. So let me look here. So this address right here is the cloud endpoint into my farm. So even though I'm on that virtual machine now, I should be able to come out here and open a new browser window here. Paste this in, and we're hitting that farm. So if you want to play along at home, you could go to this website on your device right now, and you would hit this farm, and you would get this farm. Now, what's interesting is if I take that same address, let's go to port 2013, I'm going to hit my central admin site, log in. And hopefully, so I hit central admin. So here I am. I don't even need to RDP into this thing from my browser, just like you would expect. I go to the website. I can do central admin stuff on the website, going to those virtual machines. Now, what's interesting is if I come back here to just the page, one of the things I've set up, if we look at our farm here again real quick, let me find the right. if I look at this web front end here, number one, and look at the endpoints, I can see that I have an endpoint that I've labeled HTTP. You can put any name you want to there. It's on port 80 and it goes into port 80. But if I go here and do edit, what you can see at the bottom is it's telling me that, hey, this endpoint is part of a load balance set, and that load balance set has, those machines as part of the set. So if you want to like verify or validate or add additional machines to the set, you can do that from here. So now what happens is that when I'm come to the site here, you can see that I'm hitting the load balance machines, right? No, you can't see it because it's load balance, right? You have no way to know. But a quick trick is that if you come down here, I've actually modified the master pages on each one of the web front ends, which you shouldn't do in production, so I didn't tell you to do that. You can see that I've modified the master page to label the web front end that master page is being served from. And you can see that one's web front end 1. And so if I come back here and refresh the page, we get number 2 on the next one. So every time I'm refreshing, we get some round robin, and there's caching involved, so you may not get exactly the same one. But in general, we're going back and forth between the web front end 1 and 2 to show you that we have this load balancing turned on and working. And in fact, this one is using custom probes, which I'll show you in the next talk. But other than that, just stand up a virtual machine, install SharePoint, run psconfig, point it to the SQL Server database that you stood up. You have Active Directory installed. So it's really no different than what you're doing today. It's just standard SharePoint being installed on a virtual machine. It just happens to be that virtual machine is running in the cloud. So with that, I have a whole another hour and a half next door. If you're interested, I'm going to go through all the code, show you how to do this, show you how to set up developer farms, and show you how to price this out and tell your boss how much it's going to cost, and so on and so forth. And we'll do that at the end. But I do want to leave a few minutes. We have about 5 or 6 minutes left, so I want to leave a few minutes to take questions. And as we wrap up, we'll take a few questions at the end here. Yeah. And so just to summarize, right, the virtual machine, the infrastructure as a service is very powerful. It's very flexible, and it works the way you expect it to work, right? The goal is not to have to learn new skills to build these virtual machines and to use Windows Azure for building your farm. You leverage the exact same skills that you have today. Now, obviously, there are a few caveats, put this disk here instead of here and things like that, but very minor, and we'll have that guidance for you. But to get started today, just do what you know how to do today, and it'll just work when you get to Windows Azure. And definitely go down and check out the hands-on lab to see what the experience is like and to feel, how it is to run this massive number of virtual machines in the cloud.
In Asia, too.
And in multiple data centers.
Yep.
So it's a very interesting scenario. So with that, we have microphones. So if you want to step up and ask questions so we can capture it on tape, that would be awesome.
Thanks, guys.
Oh, great.
Thanks, guys, for the presentation. The question I have is, can you have different VMs in different regions, meaning like a one front end in the US and one front end in Europe, for example, with their own SQL but being part of the same farm?
So web front ends load balance geographically with the same SQL or separate SQLs?
Either or. Like, how is it possible to get the speed in Europe and the speed in the US and split the VMs in a way where the users will get the fastest response?
No. So the way that you do that is the same way that it's recommended today to do geographically distributed SharePoint farms. You would build them the same way using that same guidance. So you do, syncing and log shipping and that kind of stuff to synchronize your farms that are across multiple regions. Would be the way that you do that. But the latency, you wouldn't be able to do it SharePoint.
You actually raise a good point that's worth emphasizing as well. I think the concept of split farms, we haven't solved with Windows Azure, right? So, when we first met with the SharePoint guys, said, hey, we're going to go work on this, there's like, please don't let anyone do a split farm. And so this is, having front ends in Windows Azure and back ends using SQL Server or any sort of split therein is strictly not supported, not something, it just won't work very well using SharePoint. think the one catch that I will say is that SQL does have some ability to do always-on solution using SQL Server deployed in 2 different regions. It ends up being more of a lazy replication than it is sort of an active farm type scenario, and that is supported based on SQL Server 2012 support outside of the SharePoint world.
Thank you.
Yep.
So one of the challenges with load balancing SharePoint is that you need to be able to do sticky sessions and cookie-based load balancing. Is that? So it didn't look like it was doing that.
So you're very bright. It's a very intuitive question.
When he's going to give you bad information, he always starts with a compliment. That's what.
So specifically, this talk is about SharePoint Server 2013, which in SharePoint Server 2013, they manage the sticky sessions themselves the right way, so you don't need a sticky IP enabled load balancer. If you are using SharePoint 2010, you only need sticky IPs if you're going to do claims-based security. So, you don't need sticky IPs if you only have one web front end. So if you're in those scenarios, then you can use it. But other than that, we do have the limitation where SAML tokens need sticky IPs in SharePoint 2010.
Right. So Fizz doesn't. Fizz doesn't, right?
No.
Right.
It does. 2010. So 2010 it becomes challenging, which is why we're focusing on 2013 as really the sweet spot for doing this. And we're still working on how we can solve the sticky IP problem, but right now there's no good solution.
Okay. Yeah, and from the Windows Azure side, we know that this is a problem, and we're aggressively working on it to just solve it from the infrastructure side. So we're working on it.
Okay, thank you.
With regards to the content storage, is there any way to map portions of the data directly into, say, blob storage? For example, to serve JavaScript files via CDN or something like that? Or is that something you just have to custom code?
So in SharePoint, by default, SharePoint stores all of its content in databases in SQL.
I'm talking about like the layouts directory.
So by default, SharePoint stores all its content in content databases. The files that are on your machine, you could put those in Windows Azure Storage, and by default have those replicated to CDN locations, just as you could if you were building a PaaS application or a website or a cloud service ASP.NET application. You can put those files and serve those up anywhere you want to. Say you have jQuery.js you want to put in storage and serve that up from CDN. That doesn't really have any effect on SharePoint. That's the same for any application. So that's totally available in SharePoint storage. Where I thought you were going to go with the question is that there are third-party vendors that are going to allow you to do remote blob storage to Azure Storage, and so you'd be able to do some sort of scenario around there as well. But out of the box, we don't do that.
All right, thank you.
Yep.
You have time for one more? Yep. That's you.
Okay. If you're going to install SharePoint, you're going to need to get the SharePoint CD or the SharePoint image up onto your VM. So you could upload a 2 gig file into your VM. Is there an easier way to get at the image, or is that all what you have to do?
I didn't understand.
Yeah, can you repeat the question? I didn't quite follow.
To be able to install SharePoint, you need to get access to your SharePoint image. So how do you get access to your image from on your VM?
So there's two things, there's two techniques that I use. It depends on how lazy I am or the time of day. I'll build the image on premise. I'll just create a new VHD, and I'll show you how to do this next door. But you build the image, you install SharePoint, you install all the prereqs, you install SharePoint, but don't run psconfig, and then you can sysprep that image, and then you can copy it up to Azure, like Corey showed you, as an image file, not a disk, an image file. Or you can just go into Azure itself, file new virtual machine, download the SharePoint bits from your server or whatever, and then install SharePoint in the cloud on the fly. So there's a couple approaches you can use to do that.
I think with that, we should probably clear out, make sure there's room for the next session. So thank you very much for coming. I hope you enjoyed the rest of this SharePoint conference. We have a booth for Windows Azure down in the exhibit hall. And
I'll be there tomorrow morning for a few hours, so if you have more questions, you can stop by then and talk to me.
Great. Thanks again, guys.